Welcome to Data Science with EJD. In this video, we are looking at a very interesting uh, topic, and that is topic modeling with latent Dirichlet allocation (LDA). This borders on natural language processing somewhat because here we are dealing with text for the most part. So you want to dive into a text and see, the kind of you want to see patterns basically in that text, right? Because of course, for the most part, we're dealing with a lot of data that is numerical. So now the question is, what is topic modeling? So topic modeling is an unsupervised machine learning technique for discovering hidden semantic structures or topics within a large collection of unstructured text data. The purpose is that it is for it to group similar words together under topics and represent each document as a mixture of these topics. So common use cases, you can use it to summarize large text corpora automatically, organize documents by topic, improve search and recommendation engines, text clustering and classification, trend analysis in news or social media. So you want to just get an overview of a particular text or things like that. So what is LDA? That is Dirichlet allocation. The core idea is that LDA is a probabilistic generative model. So each document is assumed to be a combination of topics. Each topic is a distribution over words, right? Words in a document are generated by randomly choosing a topic and then choosing a word from that topic. So key assumptions, you have a bag of words. So word order doesn't matter. So whether this word comes first or not doesn't matter. Then we have Dirichlet priors, which this helps to control sparsity. That is how likely it is for documents to focus on a small number of topics. Then example, imagine a corpus of articles about politics, sports, and science. Uh, the latent Dirichlet allocation can automatically discover this as latent topics and show their representative keywords. So the question is, how does it cluster words and documents? So, so from word to topics, right? So you have levels, so you can move from words to topics. So latent digital allocation assigns each word occurrence in a document to a topic based on word co-occurrence patterns. Words that appear together frequently across documents tend to belong to the same topic, right? It's more like when you're talking about AI, machine learning, and things like that. You can always find them together. So then you can also have another level from document to topic distributions, right? So word to topic, word clusters can inform you about what a topic looks like. But when we talk about document to topic distributions now, each document gets a probability distribution over all topics, indicating how much each topic contributes to that document. Thus, documents can be clustered by their dominant topics. So this enables similar documents to cluster together in topic space, insights into the main themes of each document. So end-to-end workflow for topic modeling with the latent Dirichlet allocation. Below is a structured pipeline for practical topic modeling. So first of all, you have the first step, which is data collection, right? So you can obtain raw text data, e.g. news article, tweets, reviews, interviews, and things like that. Then number two, you can do the pre-processing. Then you clean the text, lowercase. You can make everything lowercase, remove punctuation, do stop words, numbers, and perform tokenization and optional lemmatization or stemming. Then in step three, you can do text representation. So you can create a dictionary mapping words to IDs and a corpus, which is bag of words, or TF-IDF representation. I think we've talked about TF-IDF representation at some points in this playlist. I've forgotten what exact point. Then you can train LDA model now. So fit an LDA model using the corpus and dictionary, tune the number of topics and passes, then you inspect coherence, core, and human interpretability of topics. Then you can visualize the topics now. So you use tools like pyLDAvis to explore topic term distributions and intertopic distances interactively. So in step seven, you use output. So you can use the output to cluster document, tag topic, summarize text, or fit topic distributions into downstream tasks, e.g., recommendation. So imagine you have a full Python implementation that is well organized now. So below is an example using Gensim, NLTK, and pyLDAvis on small custom data set. So I want to do our mini project now on topic modeling using a text that is self-generated, so to speak. But of course, you need to okay, let me show the line numbers for easy referencing. So here you need to install necessary packages like Gensim, NLTK. This is the first time we're coming across most of these things. I've installed them before, but so I'll just do it again, and to just say already satisfied, right? Requirements already satisfied. Yeah. So I have Gensim, NLTK, pyLDAvis. So these are good for natural language processing. Okay, so the next thing is we want to import libraries and download resources. So what we did up there was to install, right? Now we want to import. Okay, so we import NLTK from NLTK corpus, we import stop words. From NLTK tokenize, we import word tokenize. From Gensim, we import corpora. From Gensim models.LDA model, we import LDA model. From pyLDAvis.gensim models, we import Gensim vis, and then we import pyLDA VIS itself. I think this should have even come first, but it's okay. I mean, everything just works in parallel. Then here we now do nltk.download punct underscore tab. Oh, that's like punctuation, I want to believe. Then nltk.download stop words. Let's get an idea of what stop words are, right? Stop words. Um, so a word that is automatically omitted from a computer generated concordance or index. So there are words like that are very common, like D, THE, OF, words that are just very normal. Words like that are not, they don't tell you so much like that. So this has stop. Also, we download this. Then we now have an example text data. Okay, don't forget to run this. So we run this now. So this is what the code looks like. So it's running. It takes a bit of time because uh doing some downloads alongside. Okay, good. Now it's done. So download package Pong tab to so it has downloaded that. Pong tab is already up to date, and the same for package stopwords. So now it's true. Yeah. So we have everything done in that situation. So here we want to do an example text data. So we want to sample corpus. This can be replaced with your own data. So if you have data, you can actually upload like that. But here we just write this. We just make this document using a Python list, and each string of text is put in inverted commas to show them as one data point or so like that. So first sentence, you have machine learning is transforming the world of technology. Natural language processing is a subfield of artificial intelligence. Deep learning allows computers to learn complex patterns. AI applications include image recognition and autonomous vehicles. Text mining and topic modeling help analyze large collections of documents. So this is the corpus you're working with. So if you have your own data, you can upload. So here I run that. So that has been recognized. So the next thing we want to do is to pre-process that text. So we now need to do some tokenize. So we do tokenization and stop word removal. So for stop words now we say is equal to set stop words dot words English. So with this now we remove all the stop words, and then we also do tokenization removal. So for text now, we say so. You remember the text? What we have here is documents, right? So we have texts. So the text now want to work with now. So text is equal to word dot lower. So we want to convert everything to lowercase for every word in word tokenized doc. If word is alpha and word lower, not in stop words. So as far as it's any stop word will be automatically removed. Anything that is not stop word is what will remain. So we now say for doc in documents. All of this happens for for doc in this document up here. Then once that is done, we can now print the cleaned texts. So we now have the clean text. Everything is in small letter. Then you don't see things like is, off. For instance, all this is, d, a, to. All these they are stop or they are not necessary in this situation. So we now have words that really can give some meaning like machine learning, transforming world, technology, natural language processing, software, artificial intelligence, deep learning allows computers learn complex patterns, AI applications, all that. So all the E's of D are gone. Then the next thing we want to do, so this is some processing in the context of natural language processing. So then the next thing is you want to create dictionary and corpus. So here you want to create word ID mapping. So you have your dictionary, equals corpora dot dictionary dot text of the text that you have generated. Now this corpora, and I think um up somewhere, okay, we have corpora dot dictionary. Okay, is that in? Yeah, okay, yeah. We from Gensim we imported corpora. Yeah, that's why we can use it right here. So we have a function called dictionary inside of corpora inside Gensim. So we have dictionary equals corpora the dictionary of the texts. Then we convert text to bag of words vectors. So corpus is now dictionary dot doc to BOW. That's bag of words for the text we have for text in text. Then we sample that. So the first word, so sample sample bag of words. Now we have 0, 1, 1, 1, 2, 1, and things like that. In fact, I think I like to see the corpus itself. Let me just create, let me escape and create a new cell. So I want to visualize the corpus itself. Yeah, okay. Yeah, we have 0 by 1, 1 by 1, 2 by 1, and things like that. So at the end of the day, we have 32 by 1 in all. So the next thing is we want to train the latent Dirichlet allocation model. So train the LDA model. LDA model is LDA model. Corpus is corpus. ID to word is equal to dictionary. Number of topics. You can try different numbers here, right? Number of topics. We are taking two topics here now. You can make it 3, 4, 5, 6, 7 if you like. So what this will do is that it will create a topic and what's associated with that topic, right? So, but here we are doing just two. So random stage is for the two for reproducibility. Then you have 15 passes. Like you're taking 15 words. If that we'll find that out once we run the code. Then you also have per word topics. If so, that is set to true. You can now print discovered topics now. So for IDX topic in LDA model, print topics from the topics minus one. So we can print this now. Okay. So we have two topics now. The first topic, you know, has the word learning, leading, with this. So this is some kind of magnitude of that word in the text. So that's 0.049. It also comes with the same gravity for the word help. Now, this we may not appreciate the power of this so much until we have like a very large body of text. Then it can give us a lot of understanding. So we have learning, help, mining, analyze, large, modeling. So I mean, most of them have 0.049 because they maybe just appeared once in the whole text, right? But this will be uh, better handled if we have a very large body of text. So for the next one, we have learn another topic now carries learning, recognition, autonomous, include image applications, AI, and all that. So we can even so from the words put together, we can have an idea of the kind of topic that can put all the words together. Now I want to count to see this. I suspect these 15 passes we have has something to do with number of words that would be that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's only 10. Okay, so it's 10. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's 10 like that too. So if you want three topics, we can have it too. We can have three topics. So to generate 1, 2, 3 like that. So here we have modeling, text, large, help, collections, analyze, and blah blah. So it means those words together can they form a particular concept like that. So you want to visualize with pi l pyLDAvis. I believe that stands for visualization. So Python, latent Dirichlet allocation visualization, so to speak. So you can import pyLDAvis.gensim underscore models at gensimvis, import pyLDAvis to enable inline visualization in Notebook. All right, and then prepare the visualization. And so that's gensimvis.prepare LDA model corpus dictionary. And then we run this, then it outputs. I think this is going to take a bit of time. Oh, great. So it's coming. Okay, so we have this now. So we have three topics like that. So this topic one, topic two, topic three. So the first one takes like a larger share, followed by the next, which is next, and then this like that. And then we have marginal topic distribution 2%, 5%, 10% are the marginal distributions like that. And here now we have top 30 most salient terms. So that's like 10 word for each topic, right? So world, machine, technology, okay, transforming, learning, modeling. So okay, I think it's better to do it this way. So each word you look at, so this world apply appears nowhere, right? Is that true? Let me say world, okay, machine, technology, transforming, learning, modeling, text, large, help, collections, analyze, topic. Okay, this one belongs to two in general. So this one is in one. So of course, here you have the overall term frequency. Then, of course, most of these words just appear only once, so you cannot really, but I mean, this just gives us a clue. So all you just need to do is replace what I have there with a larger body of text, right? So we have saliency term W, frequency W, and we have this formula here like that, and you also have the relevance. So some tips now for real world use. So data quality matters, right? So you can clean text thoroughly. So handle punctuation, stop words, synonyms, and domain-specific jargon. Very important. Number of topics. So choose the number of topics you want. Use domain knowledge as a starting point. Then validate with coherence scores like Gensim models.coherence model. Then multiple runs. LDA can use slightly different results. Run multiple times and check stability. So as you keep running and it keeps giving a particular set of topics, then you can know that's your idea. I mean, what you need to hold on to, right? Just like we do for most machine learning tasks, by the way. So interpret carefully, inspect top words, rename topics meaningfully for your use case. For large corpora, consider Gensim models, LDA multicode for faster training. So the next is if you want to advance on what we have there, all you just need to do is you can cluster and label documents. So use dominant topic for each document to group and label them. Combine with other models, combine topic probabilities with other features and classification tasks, deploy as service. So serve topic inference via API for real-time text analysis. So I mean, this can easily develop into an app idea where people just like, I mean, when in creating things like word cloud, right? This can have a kind of bearing to see which words are most common and things like that. So this can have a kind of leaning towards that kind of thing. So the key takeaway here is that the latent Dirichlet allocation is a powerful tool to extract insights and hidden structures from large unstructured text collections. And when combined with good preprocessing and visualization, it becomes an invaluable component in text mining, natural language processing, and knowledge discovery pipelines. So here we are. If you have an idea that you want to explore, feel free to let me know. Let me also know how helpful this video is for you. If you have subscribed already, thank you so much. We are gunning for 1,000 subscribers. We have just less than 10 subscribers to hit that. So you want to make that happen. Thank you for doing that right away. Thank you. And hit the notification bell so you can always get alerted each time a new video is released. On my channel, you can become a member. There are 3 levels of membership with different perks, different special treatments attached. You want to check those out to see which one you want to belong to. And of course, be sure to like and share this video and every other video you come across so that more people can have access to the great content I have going on here. You can have access to my code sheets and data sets. Just look at the description box and you find a link to a Google Drive, and that can take you there. So download the sheets and then follow as I do it, because the best way to code is to actually code instead of just watching videos and not be able to implement anything. Okay, till I come your way again, keep doing data right. Bye.